Hello, boys and girls. It's Mrs. Faulkner. I'm here to do lesson 27 problem set with you. It asks you to use the pictures to model equivalent fractions, fill in the blanks, and answer the questions. So we're going to be looking at number 1, which has two sides to it. So 4/6. So we look up here and we know that this is split into 6. So I'm going to shade in 4 of those. I'm not probably going to shade in as pretty as you did, but here is 4/6. All right, and now it asks us it's equal to how many thirds? Well, if I look, my line is straight down this way. So I know I would color in this many, and that is 2/3. And you could also put a 2 here. What happened to the size of the equal parts when there were fewer equal parts? Well, there are fewer equal parts, but the parts are bigger. So this big rectangle here is much bigger than one of these smaller ones. So we could say they got bigger. Also, it asks what happened to the number of equal parts when the equal parts became larger. Well, then equal parts got less. So 3 is less than 6. So when we have the equal parts, they ended up getting smaller. So we could say they are less. And again, you may not have the exact same words as I do, but as long as it's close, that's fine. Looking at the next one, 1/2 is equal to. So I'm going to shade in 1/2. When I look here, I can see that these lines match up. So I know I would shade in all of these parts. So it is equal to 4/8, and I could put a 4 there in both things. What happened to the size of the equal parts when there were more equal parts? Well, you could say they got smaller. You can see in the bottom fraction strip, the pieces are smaller than definitely the one at the top. What happens to the number of equal parts when the equal parts become smaller? Well, there are more equal parts. Whoops. All right, number 2 talks about how 6 friends want to share 3 chocolate bars that are all the same size, which are the pictures down below. But when the bars are unwrapped, they notice the first chocolate bar is cut into 2 equal parts. So what you would do here is you would just draw a line, okay? That's 2. Of course, it's not exactly right, or equal, but you know what I mean. The second one is cut into 4 equal parts. So it's going to be cut here, and here, and here. That makes 4 equal parts. And then the last one, the third one, is cut into 6 equal parts. So I'm going to have a line here, one line about here, a line here, a line here, 1, 2, 3, 4, 5, 6. Again, it's not measured out exactly, but it should be close. So we've got 1, 2, 3, 4, 5, 6. So the question is, how can 6 friends share a chocolate bar equally without breaking in any of the pieces? Well, if I look, this and this part, they're all half of a candy bar. Okay? So, regardless of how it's broken up, they're all going to get the same number of piece of candy bar because each friend is getting half of a candy bar and there are 6 halves. Some candy bars have more pieces, but the halves are all equal. So I have 1/2 is equal to 2/4 because 2 of those parts is the same. And it's also equal to 1, 2, 3, 6. Okay, so that's how we can show that they are all getting the same amount. All right, looking at number 3, when the whole is the same, why does it take 6 copies of 1/8 to equal 3 copies of 1/4? Draw a model to support your answer. So if we look up here, this is eighths. So if I want to do 6/8, it would be all of these in this area. And if I wanted to do 3/4, it would be all of these in this area. So this would be 6/8. This one would say 3/4. So eighths are smaller than fourths, so you need more eighths to equal fourths. Eighths are half of fourths. So if you use 3/4, you double 3 to get 6. And so that is how you do that. All right, looking at number 4. When the whole is the same, how many 6 does it take to equal 1/3? Draw a model to support your answer. So I'm just going to draw a circle, 2 circles actually. They're not, again, not perfect, but here is going to be, it's hard to draw with these pens. We'll say this is 6th, and this one's 4th. So we are, sorry, 1/3. And this one we're going to say is 1/6. So if I look at 1/3 versus 2/6, okay? So if I'm going to color in 2/6, it's going to be there. And 2/6, or sorry, 1/3 is going to be in that area. Okay, so it takes 2/6 to equal 1/3. All right, on number 5, it talks about having a magic wand that doubles the number of equal parts but keeps the whole the same size. Use your magic wand in the space below to draw and show what happens to a rectangle that is partitioned in the force after you tap it with your wand. Use words and numbers to explain what happened. So we can see here that this one is split into force, and this one next to it is doubled, and it is split into eighths. So we started with fourth, and so to double force, I have to multiply it by 2. So 4 times 2, because double means to times 2, is actually 8. So it's 8 equal parts is what we had to come up with and to draw, which is eighths. So the parts got smaller. You can see this area is much smaller than that area. Good luck on your exit ticket.